Hello world, welcome to GenAI LLM at the Red Shift channel, and today we are going to learn a new topic called agents. Happy learning and welcome to my channel. So what is agent? We are talking agent with respect to LLM models, that is large language model. So here we are going to understand agents. An agent is a system that uses large language model as its core engine. Okay, basically what happens when LLM is used, sometimes it fails to give the desired result. So if to overcome those kind of things in a hallucination perspective, an agent has been used. So LLM, when prompted in domains in which they do not perform well, they often fail to generate the answers. So we expect what we expect from them. So purpose to overcome those LLM weaknesses in domain like logic, calculations and search is by creating agents. The key features of agents are: agents can execute tasks by using tools effectively to generate better outcomes. So agent is basically using tools to provide a better output to compensate the LLM output which is not correct. What are tools? So tools are basically functions designed to perform a specific task. So agents have different tools which they call to give the output to the desired format and desired reasoning, and that helps the LLM outcome. So description: tools contain all the necessary information for the agent to use them effectively. The agent capabilities are to devise a series of actions or tools and execute them simultaneously. So agents, what they do, they have different tools and they can run it and execute it simultaneously to get the desired result. Execute action or tools also step by step and waiting for the outcomes before the next step. So it wait for the outcome, then it resolve it and then see it, then give to the memory and then again combine it, and when he is fully satisfied then he gives the output. So basically there are two types of agents. One is the code agent and one is react agent. Code agent workflow has a planning set step and generates Python code for for the executing all the action at the one instance. The strength is handles different kind of inputs and output types and making it deal for multi-model tasks. Whereas React agents, they are efficient mostly for the reasoning task and they follow the React framework based on a paper given by the Yao et al. In 2022. The two versions of React JSON agents. React JSON agent generates a tool called as a JSON in its output, whereas React code agent is a new type of React JSON agent only that generates its tool calls as blobs of code, which works really well for the LLM that have good strong coding performance. So here you can see there are two type of agent. One is giving the output in one step and one is giving the multi-step or the React format. So prompt is solve this problem by generating several actions to execute at once. You can use the following tools. So it's using call tool for the LLM. Okay. See, it's calling call LLM. So it's calling the large language model. And pass tool calls from output. So the code agent get the whole code block, then it execute the tool calls and finally it give the return results. Whereas the multi-step agent, you can see here in the React format, for basically used for the reasoning thing, and the one step is used for the multi-model calls. So in there also, in the multi-step, you can see the prompt solve this problem in an iterative way with a thought action observation loop. You can use the following tools. So here there is an additional parameter called memory. A prompt is combined, okay, with the memory, then they call the LLM. They pass the tool from the output. React code is get the whole code block. React JSON is pass JSON. Execute all the tool calls. Problem is solved. Then it's check yes or no. If no, then again append the observation to the memory, and again it's passed to the tools unless it get the problem correctly resolved, and then it results is returned. Let's see the example here. The agent.run. How many more blocks in bird case encoder than the encoder from the architecture proposed in the attention is all you need paper. So basically the output or the result of this will be 6. But see how this is solved by using agent. So first a BERT block is created. Search query is number of blocks in the BERT base encoder. Okay, then the output will be 12. The age, and then it's again agent is executing the code below for the attention layer for the from the paper attention all you need. The query is number of layers in attention is all you need. The output will be 6, n is equal to 6. Now when it's now finally differentiating the BERT blocks minus the attention layers, and the final output is 6. The whole steps are done behind the scene, and the final answer is with the reasoning it giving us difference in blocks is 6. So how can I build an agent? To initialize an agent, you need these arguments. So first is the LLM to power your agent, because that is basically the brain. The agent is not exactly the LLMs, it's more like the agent is a program that uses LLM as its engine. So LLM is an engine, and agent is just a program which is using LLM. A system prompt will be needed, what the LLM engine will be prompted to generate its output. Toolbox from which the agent pick the tools. There are very much predefined tools also, and you can create your new tools also. Pass, 4 point is pass to the extract from the LLM output which tools are to call and which argument which has to call. Now in the next session I will show you the coding part, how an agent is used and how we can create our own tools and many more. So stay tuned. Thanks for coming. Please like and subscribe.